If capturing design experience is crucial to mastering software development, that begs the question, what are the appropriate methods and techniques for conveying and preserving this information? Naturally, we'll be focusing on the use of software patterns. A software pattern is essentially a description of a solution to a common problem that arises when you develop software within a particular context. We'll be talking about a very specific case study throughout these lessons, but it's important to realize that software patterns are applicable to many different contexts and many different domains, ranging from mobile software development to avionics and aerospace, to electronic trading systems, automotive, web services, and many other things in between. Some of the key things that software patterns allow you to do is to be able to help improve software quality and developer productivity via a number of different means. One thing a pattern does is it allows you to name a recurring design structure. For example, one of the classic design patterns from the Gang of Four book is the observer pattern, which defines a one-to-many dependency between objects so that when one object changes its state, all of its dependents are automatically updated. If you take a look at the observer pattern description, you'll see a number of other things there as well. Patterns also help by specifying design structure and explicitly identifying key properties of classes and objects. Be aware, by the way, that we use the term class and object loosely. Patterns are applicable to many other things besides just object-oriented programming languages like Java, C#, or C++. If you take a look at the diagram that we show here, you'll see that it helps to convey several key things. It shows the common roles and relationships. It shows there's something called the subject, which is one of the roles. It shows that this subject is related to several other entities called observers. The dependencies between the subject and observer are also noted as well. When something changes state, then the subject is responsible for calling the update method on all the various observers. And these interactions are explicitly captured and conveyed in the pattern description. Patterns also help to document important conventions. For example, when an update method is invoked on a particular concrete observer, it probably should be careful not to block for long periods of time, because that will starve out other observers that may be waiting to be notified as well. The other things that patterns help to do is they help to abstract away from concrete design elements, helping to make software more retargetable, more flexible, more reusable. For example, the observer pattern can be described and applied in a variety of different problem domains. It can also be used in a variety of different form factors, from handheld devices up to large-scale servers. It also, of course, is not dependent on any particular vendor or other types of technology. And naturally, it's also independent of particular programming languages. So one of the other nice things that you get by applying patterns is they help to distill and codify knowledge that's gleaned by experts from their successful design experience. Needless to say, the observer pattern didn't just appear out of thin air. It grew out of decades of expert use in a variety of different contexts. In fact, if you go back and take a look at some of the early work that was done with Smalltalk back in the 70s and 80s, you'll see a number of great books, classic works of literature in the field, talking about the use of the observer pattern in the context of something called model view controller, which is part of the Smalltalk environment. The observer pattern is also applied in other contexts as well. If you take a look back in the early 90s, there was something called tool talk, which was a way of being able to interact between various distributed components in a networked environment. Once again, observer gets applied. So the nice thing about patterns is they help us to avoid reinventing the wheel for common software problems, so you can spend more time developing your application logic and meeting your customers' needs.